horizontal support, there is a massless rod. This is a massless rod. We say, let's say AB is a massless rod, and right now this is in horizontal position. These are two strings which are tied from the ends to this ceiling fixed support, which are making angle of alpha and beta, and from here to here at a distance x, mass m is hanging. Distance from here to here is x, distance from here to here is y, right? So obviously the strings, the tension, the strings over here, we can take it as T1 and T2. We are just interested in writing the equations for translational equilibrium and rotational equilibrium. We are not bothered about solving it, what is the value of T1 and T2, etc. This is a small thing. Let's understand the concept and just write the equations for translational equilibrium and rotational equilibrium. So we say that is, first of all, we draw the force diagram for this. So the force diagram for this, it is something going to be, we say this is A, this point is B, and over here the force which is acting is M into G. This is X, this length is Y. So total length of the rod is X plus Y. This T1 can be broken into two components. So if this is T1, this angle is beta, so this angle is also beta. So this is going to be T1 cos beta, so this is going to be T1 sin beta. This we have taken T1, so let's take it as T2. So if this is alpha, so this is alpha. So this is T2 cos alpha, so this is T2 sin alpha. So we break this in two components. Over here we have broken it. Let's draw these forces also. So this is T1 cos beta and this is T1 sin beta. And over here this is T2 cos alpha and this is T2 sin alpha. All the forces they have been drawn, right? So now first we can talk the translational equilibrium. It means that net force along x-axis is equal to 0 and net force along x-axis is equal to 0 and net force along y-axis also should be equal to 0. Let's see if first along the forces along the x-axis, net force along x-axis should be equal to 0. So T2 cos alpha is equal to T1 cos beta. If this force is stronger than this force, this will move in this direction. If this force is stronger than this force, this will move in this direction. But this is not moving along the x-axis. So this force is equal to this force. Similarly, this rod is not moving on the y-axis. That is upward force equal to downward forces. So when we say summation of force along y-axis is equal to 0, so this means T2 sin alpha plus T1 sin beta, this plus this is equal to mg. Right? So these are translational equations. Now let's make the torque equations, that is rotational equilibrium. This rod is in equilibrium, this is in rotational equilibrium also. This is not rotating about any axis, this is not rotating about A also. So torque about A should be equal to 0. When torque about A should be equal to 0, then the torque of this force and this force, that will also become equal to 0. That is, torque is force into perpendicular distance between line of force and axis rotation. Torque of this line of force is passing through this axis only. This is also passing through the axis only. So this job is done, this job is done. Similarly, torque of this force, if you see the line of force, this is also passing through this. So this job is also done, work is also done. Torque of this force about this axis, that will also equal to 0. As the torque of this force and this force about this axis is equal to 0, because the distance between the line of force and axis rotation is equal to 0. They are passing through the line of, these line of forces of these forces, they are passing through the axis of rotation also, only. So mg is trying to rotate this way, T1 sin beta is trying to rotate this way. So mg, this force into this distance, y. This is trying to rotate it in this direction, that is clockwise movements. And T1 sin beta is trying to rotate it in the anti-clockwise direction. So T1 sin beta into distance from here, that is x plus y. We get an equation. If we take this, if we say torque about B is equal to 0, then obviously torque of this force is equal to 0, torque of this force is also equal to 0, and torque of this force, this also, the line of force is also passing through this axis only. So torque of this force is also equal to 0. So torque of this force 0, this force 0, this force 0. So now remaining forces, they are only T2 sin alpha and mg. Now it is hinged over here. We have put a nail over here. This force is trying to rotate this way and this force is trying to rotate this way. This is not rotating in any way. So it means clockwise movements is equal to anti-clockwise movements. So torque of mg, that is trying to rotate anti-clockwise direction, that is mg into this distance x, we can put it in bracket so that multiplication is not confused with x, is equal to T2 sine alpha into x plus y. We get one more equation. If you wish to take this axis also, that is, we are free to choose. We can take this axis also. So now if we take this axis rotation, the torque of this force comes out to be equal to 0. This is passing through this axis only. Let's call it C point. Torque of this force equal to 0. Then this line of force passing through the axis only. Torque of this force equal to 0. And torque of this force also equal to 0. So now we have forces into consideration. This force, these are only two forces. Rest is torque of this force about this axis equal to 0. So now if we take this as acceleration, that is, we put a nail over here. So T1 sine beta tries to rotate this way, whereas T2 sine alpha tries to rotate this way. So we say if torque about C is equal to 0, net torque about C is equal to 0, that is of this T1 sine beta into x. T1 sine beta tries to rotate it in the anti-clockwise direction, whereas T2 sine alpha tries to rotate it in the clockwise direction. So clockwise movements is equal to anti-clockwise movements, or anti-clockwise movements is equal to clockwise movements, is equal to T2 sine alpha into y. We get one more equation. So if the values they are given in the question, you can put the values, and whatsoever is required, you can find the answer.